Welcome to section 7.5. Today we're going to complete the whole circuit, starting with an IVP and going all the way around to getting a solution. Let's start with formulas 19 and 20, which we'll be using a lot today. L of y prime is S big Y minus y of 0, that's little y of 0. And L of y double prime is S squared big Y minus S little y of 0 minus y prime of 0. Okay, I'm doing this video in two parts because the problems are really long. Today we're going to do 3 problems and then I'll end the video and we'll pick up and finish it off. Comments on notation. And I'll demonstrate this as I go through the 3 problems that I'm going to do today. Every problem needs to start off with taking L of both sides. Then you're going to solve for big Y, and that might take a while, but at some point you should have a line that looks like Y equals some function of S. And make sure I can tell the difference between your little y and your big Y. Then, once you've got big Y cleaned up, you're going to take L inverse of both sides. L inverse of big Y is little y, by definition. And so your final answer will be y equals some function of t, and you do need the y equals, and it's best, you know who I'm talking about here, it's best if you could please put the y equals on the left and not the right. Okay, here we go. So let's start with number 6. We're going to start by taking L of both sides. Remember, if I'm going too slow or too fast, you can speed me up or slow me down through the magic of YouTube. 4e to the 3t. Okay, now L of y double prime is S squared big Y minus S y of 0. So that's 2S. Minus y prime of 0, so that's minus 7. Then we're going to go minus 4, bracket, because L of y prime has 2 terms, S big Y, minus y of 0, which is 2, and then plus 5 big Y. L of little y is big Y. And that equals L of 4e to the 3t, which is 4 over s minus 3. All right, let's combine all the terms on the left that have a big Y in them. So we've got big Y, s squared minus 4s plus 5. And then we'll move anything without a big Y to the other side. So positive 2s. And then I've got positive 8. And negative 7 is positive 1, so I'll move a negative 1 over here, and then plus 4 over s minus 3. Okay, let me write this as a single fraction. This is 2s minus 1 times s minus 3 plus 4. And the common denominator is s minus 3. Okay, divide both sides now by s squared minus 4s plus 5. And we get big Y equals, big fraction, on the bottom I'll have s minus 3 times s squared minus 4s. I'm trying to make my s's not look like 5s. Minus 4s plus 5. And then on top, I'm going to take this expression and multiply it out and collect like terms. So I'll have 2s squared minus 7s plus 3 plus 4 is plus 7. Okay. Now, I'm ready to take little L inverse of both sides. So little y, and if you can't tell the difference between little y and big Y, then write little y of t. to make clear it's not big Y. Big Y is a function of S. Anyway, little y is L inverse of this expression here, of this fraction. But I'm going to use the partial fraction hint at the top and rewrite that fraction as 2 over s minus 3 plus 1 over s squared minus 4s plus 5. Okay, so let's pause and look at what we've done. First step, take L of both sides. We did that. Then at some point, you want to have a line that looks like y equals blah. That's right here. Then you take L inverse of both sides and you get little y is L inverse of some expression. And now we can write down that expression in terms of t, almost. Let's rewrite this first. This is L inverse. I have no problem with the 2 over s minus 3, but for that fraction with the quadratic in the denominator, I'm going to have to complete the square to find L inverse. So let's write that as s minus 2 quantity squared. That'll give me s squared minus 4s plus 4, but I have plus 5, so I want to add 1. So for this expression, I'm going to use number 8 in my table. I have my table here to the left of me. Let me just check. Yeah, it's number 8 with a equal 2 and b equal 1. So little y of t, you can just write little y, you don't have to write y of t, is 2e to the 3t plus e to the 2t sine t. And that's our answer. Piece of cake. And the initial conditions are already built in, so there's no constants that we have to solve for. All right, next problem. I put a condensed version of our table there to the right, so we can use that. We're going to start off with L of both sides. So we have L of t squared plus 2. Okay, now L of y double prime is s squared big Y minus s y of 0. So 4s minus y prime of 0, so plus 1. And then plus L of y, L of little y is big Y. And that's equal to L of t squared is, by formula, I guess it would be 2 in my table here, 2 over s cubed plus 2 over s. Now the hint is if we write L of t squared plus 2 as a single fraction, then we're not going to need to use partial fractions. So let's take that hint and write that as 2 plus 2s squared over s cubed. Now I'll be able to pull a 2 out in a minute and cancel the s squared plus 1. On the left, I've got s squared plus 1. I want to collect all the terms that have a big Y in them, and then take terms without a big Y and move them to the right. So 4s minus 1 plus, I'm going to write this fraction as 2 times 1 plus s squared over s cubed. Okay, now to get the y equals blah line, I'm going to divide both sides by s squared plus 1. So big Y is, I'm going to write this as 2 separate fractions. 4s over s squared plus 1 minus 1 over s squared plus 1 plus 2 times 1 plus s squared over s cubed times s squared plus 1. Now, s squared plus 1 is the same as 1 plus s squared. Those cancel. And I'm ready to take L inverse. And I never needed partial fractions. So little y is L inverse of 4s over s squared plus 1 minus 1 over s squared plus 1 plus 2 over s cubed. All right, so our final answer is little y equals 4s over s squared plus 1. So that's going to be number 7 over here. That's going to be 4 cos t. And the next one is going to be minus sine t. And then for L inverse of 2 over s cubed, that's just t squared. All right. Okay, we're almost there. Solve for y of s. So you have some homework problems like this, and I wanted to do one like this just so you know where to stop. So this is not a complete problem. If we look at our picture in the beginning of the circuit, if you're just solving for y of s, you're stopping here. And so you don't have to do this last step where you take L inverse of both sides. So those problems are going to go a little quicker. So this shouldn't take us long at all. We start off like we start all problems that when we're solving for a DE, we're going to take L of both sides. Y double prime plus y equals L of 5t squared minus 3. All right. S squared big Y minus s y of 0. Well, y of 0 is 0, so that term will be 0. And then minus y prime of 0 is plus 7, because y prime is negative 7. All right, and then plus big Y equals L of t squared is 2 factorial, which is 2, over s cubed. So 2 times 5 is 10 over s cubed. And L of 3 is 3 over s. All right, so combine all the terms on the left that have a big Y in them. And then move the 7 over. Okay, and now I'm going to write, before I divide both sides by s squared plus 1, I'm going to write this as a single fraction. So my common denominator is s cubed. So to get negative 7 over s cubed, I'm going to go negative 7s cubed over s cubed. 10 already has denominator s cubed, so plus 10. And then I need to multiply the 3 over s by s squared over s squared, so minus 3s squared. Okay. Now, last step, big Y is negative 7s squared plus 10 minus 3s, sorry, that was negative 7s cubed plus 10 minus 3s squared over s cubed times s squared plus 1. And this is all we had to do, solve for y of s. So we're done at this point. If we had to, complete the problem and find little y, then we would definitely need partial fractions on that, and that would be one where we'd want Symbolab, because that's going to have, that would have 4 fractions, and one would have a linear top. All right, so I'm going to end this video, but while we're gone, I'd like you to do practice 1, practice 2, and practice 3, and then check in with me on the next video, and I'll do practice 1 and practice 2 on the video, and then practice 3, I've put the solution at the end. Okay, see you next time.